Dear students, welcome to our class on climate change, CO2 levels and trends. We are going to discuss. Once we start learning climate change, basically the steps involved are land use change, first step. Second step is fossil fuel burning. Because of both land use change and fossil fuel burning, there is a global warming, not global cooling, global warming because of greenhouse effect. Now, land use change, fossil fuel burning, through greenhouse effect, globe is getting warmed up. Now, what are the consequences? That's what we discussed in the earlier classes. Now, in today's class, we try to understand what are the CO2 changes or trends. Now, the first point is evidence from polar ice core samples show that CO2 level in the air has over centuries increased from 280 ppm in 1773 to 330 ppm in 1973. That means in 200 years there is only an increase of 50 ppm, 1773 to 1973. However, the next increase of 50 ppm, that means from 330 to 380 ppm, it has just taken 33 years only. 200 years, 280 to 330. Just in 33 years, 330 had become 380. Now, let us see. The CO2 has increased at the rate of 1 ppm from 1960 to 70 and 1.5 ppm per year from 1970 to 2000. You see, for 10 years, just 10 years, only 1 ppm. But 1.5 ppm from 1970 to 2000. Then let us see what happened. In the decade 2001 to 2010, in this decade, CO2 emission had been 2 ppm per year. Okay, now the current level, it is 3 ppm per year. You see the increase. Now, at this rate, the CO2 concentration by 2050 will be 510 ppm. The normal value of CO2 concentration assumed in agricultural meteorological studies so far is we agrometeorologists take 330 ppm. So, by middle of this century, CO2 concentration would have increased by 50%. Now, another few most important point for today's class is that vegetation is both source and sink of CO2, and normally it is taken as carbon neutral vegetation. Now, decay of organic matter, industrial emissions and burning of biomass also release CO2 into the atmosphere. However, the major cause for sharp increase in CO2 emissions is due to the burning of fossil fuels. Maybe it is for industrial purposes, for transportation, even in the transportation, road, rail, air, ocean, water. Okay. Now, which injects into the air CO2 equivalent to 6 ppm. Once again, I will read. However, the major cause for sharp increase in CO2 emissions is due to the burning of fossil fuel, which injects into the air CO2 equivalent to 6 ppm. Now, forests cover 1/3 of the land surface, okay, lithosphere. Okay. However, it contributes to 2/3 of the photosynthesis. Okay. Now, so thus the forests constitute a major terrestrial sink for CO2, of course, as important as the ocean also. Deforestation contributes in a negative way to build CO2 in the air, okay, to the extent of 25% that of fossil fuels. Fossil fuels, X. In the fossil fuels X, 25%, X usually from deforestation. Now, for CO2 concentration to double the 2000 value of 370 ppm in 2010, as envisaged by IPCC, the average annual emission level has to increase by 50% compared to present levels. In 2010, what is the value? It is going up to 3 ppm. Now it has to increase by another 50% by 2050. Why? Because for CO2 concentration to double as per the IPCC, Intergovernmental Panel on Climate Change estimation. Now, another interesting point is an increase of 25% of fossil fuel burning or decrease in the capacity of both terrestrial and ocean sinks for CO2 can lead to above. Okay. Now, the last point is considering the history, please listen very carefully. Considering the history of CO2 emissions and absorption from the beginning of this century, this possibility cannot be termed unlikely. Thank you very much.